Let's start with question number 9 of exercise 7b. So it's given, if y is the mean proportion between x and z, show that xy plus yz is the mean proportional between x square plus y square and y square plus z square. See, we have to show something, we have to prove something. So in this type of questions, first thing which we have to see is what is given to us. So there it's written if y is, so that means this thing is given to us. If y is the mean proportion, see, mean proportion, it's a word which we have learnt while doing continued proportion. So what is continued proportion? If a, b and c, these are three different quantities, then ratio of a by b, or ratio of a is to b, it is proportional or equal to ratio of b is to c. So this is given to us, which implies that b square is equals to ac. So this is a story about continued proportion. So this word mean proportion we did there. Now b square is the mean, b is the mean. So in continued proportion, the square of the mean proportion, it is equals to the product of first and third proportion. So same way here, y is the mean. So here three numbers, instead of a, b and c, it's x, y, z, three numbers are there, and y is the mean proportion. So that means the square of the mean proportion, it is equals to product of first and last, first and third proportional, first and third proportional. So this thing is given to us, I can write it as given. Now given part we have understood what is given. Now let's see what we have to prove or what we have to show. Show that xy plus yz, it's the mean proportion. So this is the mean between these two. So that means now my ABC, A is x square plus y square, mean will come in the middle. So this thing we have to prove as the mean. So we will write in place of b xy plus yz, and this as c y square plus z square. So these three terms are there. So this is the mean proportional we have to show. So that means if this is the mean proportional, we have to show that square of the mean proportion, it is equal to the product of first and last proportional, or product of first and third proportional we can say. So while proving anything, see, we have to take two different sides and we have to solve it, and we have to show that this side is equals to this. So I'll start with left hand side. This is left hand side and this is my right hand side. So it's given xy plus yz whole square. First thing we can see, if anything is common, that we can take it out. So here we can see this y and this y is present in both. So I'll just take it out, y x plus z, remaining numbers as it is we can write. See, this square is there, whole square. So this is with y also, because from inside the bracket we are taking it out. So this means I will just write whole square, because this square means this is with all the terms which are inside the bracket. So y we are taking out. So this square is with this also and with y also. So separately I can write, because this whole bracket means this power is with y also and with this also. So I will just write it as y square and x plus z whole square. Separately I have written this square power. Now y square, see, y square is equals to x into z. So in place of y I will write x into z, and x plus z whole square as it is I will write. So this is my left hand side after solving it. Now let's start with right hand side. See, here if you want, this whole square is there, you can expand it, like a plus b whole square is a square plus b square plus 2ab. Here a and b is x and z. You can expand it and then do the multiplication also. If you don't want, you can write it like this also and prove right hand side equal to this. both ways are fine. Prove means anything we can do, but our left hand side should be equal to right hand side. So I am just leaving it here only. Now let's do this one. Right hand side, it is this, I have already written. So x square plus y square into y square plus z square. Now I have told you, wherever we see we can utilize the given things, there we have to use it. Y square, y square, y square, y square. So value of y square is given to us, so we can substitute here. Y square is xz, so x square, in place of y square I will write its given value, that is xz. Then again here y square is there, y square is equal to x into z plus z square. So x square means x into x. X, when it is getting multiplied by itself, that it will become x square, like 2 into 2, 2 square, 3 into 3, 3 square. Same way, x into x, x square. I have just written it in expanded form into xz, xz plus z into z. So why I have written in this way? Because I have to show that this x is present in both the terms, and here z is present in both. So that is why, if directly you can see that this x is common and here z is common, so directly you can take it out. So I just want to show you, so that's why I have written one extra step. The expanded form of x square and z square I have written. Now x, I will write it outside, remaining terms I will write as it is. So x is there and here z is there, because this 2x we have written outside. Same here, z is common, so we have taken it out, x plus z. Now all these terms are getting multiplied. So x into z I will write at the starting, then x plus z into x plus z. Here x into x, x into x, x square, x plus z into x plus z. It will become x plus z whole square. And moreover, we have learnt in exponents also that if bases are same and they are getting multiplied, we can add the powers. So 1 plus 1, 2. So now we can see that this side we got xz into x plus z whole square. This is my right hand side. My left hand side also, what I proved, xz into x plus z whole square. See, my left hand side is equal to right hand side. So this is what we have to prove, that this is equal to this. So hence proved. In 10th question, it's given if Q is the mean proportional between P and R, show that PQR into P plus Q plus R whole cube, it is equals to PQ plus QR plus PR whole cube. So it's similar to the previous question, so you can also try with me. These questions are really simple. See, we just have to prove by using the given thing. So given is that thing in which is they have mentioned with if this thing is there, then show. So if the word if, wherever it is written, that means after that word the given things they have mentioned. So Q is the mean proportional. Mean proportional, I told you, it is something related with continuous, because in continued proportion we have three terms A, B, C, and B is the middle one, is the mean proportional. And we know mean proportional, the square of the mean proportional, it is equals to the product of first and last proportional. So here Q is the mean proportional. So I can write A is equals to P, since Q is the mean proportional, so B is equals to Q and R is equals to C. So accordingly we have to substitute the values in this formula. B square is equals to AC. So B is Q, so Q square is equals to PR. This is given to us and we have to show that this is equal to this. So show means again we have to prove that left hand side is equals to right hand side, and the proof we have to do by using the given things. So let's start. I will start from left hand side. It is PQR into P plus Q plus R whole cube. See, PR is equals to Q square. PR. Here if you see, it's P into R. PR means P into R. If Q I will just write here and PR I will write together. P plus Q plus R whole cube. See, all these P into Q into R, if they are written together, that means they are getting multiplied. All the alphabets, when they are written together, they are getting multiplied. See, there is no other sign. If there is other sign is there, it's fine. If no sign is there, that means they are getting multiplied. So I have just written in this form, Q into P into R. PR I have written together. Why I wrote it together? Because PR is equals to Q square. So I can substitute the values. Now Q into PR is equals to Q square. So Q square I will write P plus Q plus R whole cube as it is. Now Q into Q square. See, this is Q to the power 1. Q means Q to the power 1. And if nothing is written between these two, dot also means multiplication. If nothing is written, that means they are getting multiplied. Bases are same, so powers you can add. 1 plus 2, 3. See, if bases are same and they are getting multiplied, so you can add the powers. So 1 plus 2 is 3. So that's what I have done. P plus Q plus R whole cube. I can write, because with Q also and with this bracket also, cube is the power, 3 is the power. So I can just write the power single time. Instead of writing it 2 times, let's write it single time. If I put whole bracket and this power I write outside the bracket, that means this power is with this also and it is with this also. See, Q cube into P plus Q plus R whole cube. Now this you can just Q, you can multiply, so it will be P. See, outside the bracket, whichever term is written, that will get multiplied with all the terms inside the bracket. So Q will multiply it by P also, Q also and R also. So it will be PQ plus Q square plus RQ or QR whole cube. Because this cube as it is we have to write. So this is left hand side after solving it. Now let's start with the right hand side. Right hand side, whatever they have given, that value only we have to use. So right hand side is equals to this thing, PQ plus QR plus PR whole cube. Now just see, observe it carefully. Can we use anything? Can we use the given thing in any way? Q square is equals to PR. Q square is equals to PR. Here see the third term, it is PR. So PQ plus QR plus PR. See, PR. PR is equals to Q square whole cube. See, PQ, PQ, RQ means QR, same thing. Because when we multiply two terms, like 5 into 2, if I multiply, 5 into 2 is also 10 and 2 into 5 is also 10. So that means QR and RQ, if I write both ways, it is correct. So PQ, PQ, QR plus Q square plus Q square whole cube. See, this is equal to our left hand side, hence we can write it as it is equals to left hand side, hence proved. In 11th question, it's given, if three quantities are in continued proportion, show that the ratio of the first to third is duplicate ratio of first to second. See, before we do this question, I'll explain you the meaning of duplicate ratio. Ratio means writing any number in fraction, like A by B, A is to B, I can write it as A by B. That is the ratio of A and B. Now if I have to write its duplicate ratio will be A square by B square. Only that square we have to do. So I'll take example by taking number also. If I have any number like two numbers, or ratio of two numbers like 1:4. 1:4 I can write it this way, and its duplicate ratio will be 1 square is to square of 4. that means it will be 1:16. If I have to take the duplicate ratio of 5/9, so its duplicate ratio will be 5/9 whole square, or 5 square by 9 square. So it will be 25/81. So duplicate you just can remember that it is related to square. Whatever the ratio is given to us, we just have to do its square. That will be the duplicate ratio. Now let's start with the question. So what they are saying, if three quantities are in continued proportion. So three quantities we can just assume as A, B, C, like we are doing from the starting. So A, B, C are in continued proportion. So in continued proportion, we know that square of the mean, it is equals to the product of first proportional and third proportional. So B square is equals to AC. It is there in continued proportion. So they are saying if three quantities they are in continued proportion, then show that the ratio of first to third. See, this is my first proportional, mean proportional and third proportional. So ratio of first to third, see this thing A is to C is the duplicate ratio of first to second. See, if I have to do its duplicate ratio, I told you directly square we have to do. So but which square we have to do? Duplicate ratio of first to second. Duplicate ratio means square, but square of first to second I have to do. So they are saying if these three they are in continued proportion, then we have to show that ratio of first to third, it is equal to the duplicate ratio of first to second. So this thing we have to show, or we have to prove. See, everything was written in the statement. I have just converted it in the ratio form. It was written to us, it was given to us in the English language, we converted it in the mathematical language. So ratio of first to third is this. Duplicate ratio means square. Duplicate ratio first I told you it is A, second is the mean, and third is C. So duplicate means square of first to second. So this is given. I will write B square is equals to AC, and this thing I have to show. So let's start. In show means I have to prove right, left hand side equals to right hand side. So let's start. So let's start with the proof or solution. We can write, I'll start from the given things. See, this is given to me, B square is equals to AC. So B square is equals to AC, I can use. See, we have to focus what we have to prove. So anything we can do, any change which is acceptable we can make here. So now if I see in the required thing, I have square of A and square of B is also there. So if I see in the given thing, square of B is already there, but I need square of A also. Other two things are also there, A and C, it's there. So I just need square of A also. So how can I get square of A? So what I will do, multiply both sides by A. Multiply both sides by A. See, why I told you in previous videos also, whenever we solve equation, I told you that whenever we make any change in the equation means wherever this sign of equality is there, we can make that change on both sides of the equation. Why? Because when we make change on both sides of the equation, see, this term is getting multiplied here. If I shift it this side, it will get divided. So this and this will get cancelled, and I will be left with the given thing, that is B square into B square is equals to AC. So that means whenever we make any change on both sides of the equation, it doesn't make any change. I have shown you also, if this 2 and this A and this A, it can be cancelled. So that is why I made this change. Now a square b is equals to this. When we multiply this a and this a into a, it will become a square c, because these all are terms getting multiplied. So if we apply the rules of exponent also, bases are same, and if they are getting multiplied, powers we can add. So 1 plus 1, 2. So that is how I got a square also. Now let's write together the terms which are with square and the linear terms, like whose degree is 1, we can say. So a I will write this way, this side only. C I will shift to this side. See, C is getting multiplied. C is getting multiplied with a square. So if I change its side, it will get divided. So a by c, I will get this side a square is already there, and this here b square is getting multiplied by a. If I change its side, it will get divided. So a by c is equals to a square by b square. A by c, it is equals to a square by b square. So this is what we had to prove, hence proved. In 12th question, it's given, if y is the mean proportional between x and z, prove that this is equal to this. See, let's start from the given things, and this question, see, you also try along with me, because I feel now the concept is very much clear. In almost all the questions, given thing is that this thing is the mean proportional between. So only one thing we are using, that b square is equals to ac. So try to do this question along with me, and then you can refer. This way you will also get the experience how to solve it. Now let's start. First we will write the given things. Y is the mean proportional. That means I will just write in this form first. Mean proportional means the numbers are in continued proportion, and the middle one, which is mean proportional, its square is equals to product of first and third proportional. So this is given to me, but instead of ABC, it's given to me x, y, z, which implies here I will just substitute the values of A, B, C as x, y, z. So B is y. Y is the mean proportional. So y square is equals to x into z. This is given to us. So in proof, we have to prove that left hand side is equals to right hand side. So we'll start with left hand side. It's x square. See, wherever you see y square, you can just write y square is equals to xz. Now first I will just write it down, x square. Y square I can write it as x into z. Here y square is there. This left hand side I am going to solve now. So x square as it is I have written, y square it is given to us xz, x into z. So I will write as it is plus z square. Now in denominator, see, this is one fraction only. In denominator, if we see, all the powers, they are negative. So negative powers we can change to positive by doing the reciprocal of the numbers, because negative powers we cannot solve further, so we have to make them positive. X I can write it as x by 1 whole power minus 2, y I can write as y by 1 whole power minus 2, z I can write as z by 1, because nothing is there, so 1 we can write. Now when we do its reciprocal, x by 1, it will become 1 by x. Xy, because reciprocal means changing of numerator into denominator and denominator into numerator. So power, it will be changed from negative to positive. So square minus 2 to plus 2 it will be changed. Minus same 1 by y whole square plus 1 by z whole square. So x square minus xz plus z square upon, see, whole square means the square is with 1 also and with x also. So I can write it as 1 by x square. because 1 square is 1. If you multiply it 100 times also, it will give you 1 as the answer. So 1 square is also 1 into 1, that is 1. So that is why directly I have written it as 1 minus 1 by y square plus 1 by z square. X square minus xz plus z square upon 1 by x square minus 1 by y square. Y square is equals to xz. So here also I will write the value of y square. The given value given is this, y square is equals to x into z. So I have just substituted the values upon plus 1 by z square. Now this, if only we see the denominator, this thing, this is like addition of fractions, addition of positive or negative integers. So here denominators are not same. When the denominators are not same, we take LCM. So same thing, don't get scared that this is x, y, z or ABC. Same way like we do with the numbers, here we have to consider these as numbers only. So we will take the LCM of x square, xz and z square. Numerator I will write as it is, x square minus xz plus z square. So denominator here it is x square, xz and z square. So LCM will be, LCM, see here only two numbers. We have to consider this alphabets as number only. We have two numbers only, x and z. So how to take LCM? So LCM whenever we take, it's the highest power of the given expressions. So when we take LCM of 1 by 2 and 1 by 4, when we are taking this LCM, what will be the LCM of 2 and 4? It will be 4, because 2 is 2 to the power 1 and 4 is 2 to the power 2. LCM will always be the highest power of the given numbers. So 4 is the LCM here. So same way here, you just have to see everything is same, nothing is different here. X and z is the two numbers. So highest power of x is x square and z is z square. So LCM of this expression will be x square and z square. So like the way we solve LCM, we will do 1 by x. I have found the LCM, that is x square z square. Now LCM we have to divide by denominator. So x square z square will divide by denominator. Division simple, x square z square by x square. Like the way we divide by using fractions, also you can do direct cancellation, we can do this way easily. So x square and x square will get cancelled. So z square is the answer. When we divide these two, that z square we have to multiply with the numerator. So 1 into z square is z square minus, now LCM x square z square I have to divide by denominator. So x square z square divided by x z. Square means 2 times x. So this x will get cancelled with this 1x. This z also it will get cancelled with 1z, because x square is x into x and z square is z into z. So 1x and 1z will get cancelled. So x and z we are left with. So we will multiply x and z with the numerator. So 1 into xz is xz plus z square. Again this LCM x square z square we will divide by x square z square, we will divide by denominator. So z square and z square will get cancelled. So we are left with x square. X square is the answer. So x square we have to multiply with the numerator. So I got the terms of numerator also now. Z square minus xz plus x square. Now this is one fraction and this is one fraction. Two fractions are getting divided. So this fraction also we can write it as 1 here. So in next step we can do. So this number it is getting divided by this. So what we can do here, see x square minus xz plus z square. This we can write it as by 1. because see this is one fraction, so let's write numerator also in fraction form, so easily you can solve the division of two fractions. This as it is this sign now. This number I have just written in the fraction form. By 1 if we write, it won't make any difference. So z square minus xz plus x square by x square z square. So two fractions are getting divided now. So when two fractions they are getting divided, we will follow this rule. A by b is first fraction and c by d is second fraction. These ones, outer ones will multiply and inner ones we will multiply. So outer ones you can say this one and this one, these two. So it is x square minus xz plus z square. It will get multiplied by x square z square. And inner ones will get multiplied, so 1 with this, so z square minus xz plus x square into 1, no need to write. See, position of first fraction, which is the upper one, the position of its numerator and denominator you have to keep it there, only these two you have to shift. Now these two, it is plus z square plus x square minus xz, it is plus x square plus z square. So both are same terms, they will get cancelled. So I am left with x square z square. I can write it as xz whole square because 2 power, its power is 2 for x also and for z also. So instead of writing it 2 times, I have just written it single time. Meaning is same. If I write it outside the bracket, that means it is getting multiplied by both. This is the power for both. Xz, what is the value of xz? Xz is y square. Y square as it is, I have to write only in place of this y square, and this power 2 as it is I have to write. So when one single number is there and 2 powers are there, the powers will get multiplied. So 2 into 2 is 4, y to the power 4. Here also if I see my right hand side is equals to y to the power 4. So it is equal to my right hand side, hence I have proved both the sides equal to each other.